A next topic to take a look at is electrolysis. Electrolysis is the reverse of a galvanic cell. What we're doing is we're forcing electrons in the form of a current through an electrochemical cell to produce a chemical change, and so they are going the opposite direction they would normally go if the reaction was allowed to be spontaneous. So if we take a look at the galvanic cell we talked about earlier, where we have copper ions reducing to form copper metal, we have zinc oxidizing to form zinc ions, we get an E0 for our cell of 1.10 volts. And what we see is the electrons are here going from the zinc anode, where oxidation of the zinc is occurring, coming to the cathode, where the electrons are joining up with the copper ions to plate out copper on that electrode. Now, if I want to turn this galvanic cell into an electrolytic cell, what I'm going to do is I'm going to apply an external voltage, and I'm going to apply it directionally so that the electrons are being pushed into the zinc electrode. And what happens then is that pushes the ions, the negative ions, go through the salt bridge in the opposite direction from as a galvanic cell. And I get now electrons traveling towards the zinc. I have zinc ions being attracted to the electrode, meeting up with the electrons coming in and plating zinc onto the zinc electrode. I have copper ions being created as the copper metal gives up the electrons. And so now I have the reverse reaction. Rather than oxidizing, zinc is reducing. Rather than reducing, copper is oxidizing. Okay, we talked about the fact that we need to add current. We need to define current. Current is simply a flow of charged particles. In our case, it's going to be a flow of electrons. And they generally flow through a wire. Okay, symbol for current is capital I. The unit for currents is amps. Capital A is the symbol. And a current is a coulomb per second. We saw earlier that a coulomb is a unit of charge. And the charge on one electron is 1.6 times negative 19 coulombs. Since it's an electron, it's a negative 1.6 times 10 to the negative 19 coulombs. So if I know how many electrons are transferred, I can figure out the charge transferred and ultimately figure out the current. So if I'm plating zinc from my electrolytic cell, then I need 2 electrons for every 1 zinc. So if I'm plating out a mole of zinc, I need 2 moles of electrons. So remember, 1 mole of electrons equals 1 Faraday. So the charge on 1 mole of electrons is 96,485 coulombs. So if I want to plate out 1 mole of zinc in 10 minutes, how much current do I need? Let's figure out how to deal with this. So current is coulombs over seconds. So I need 2 moles of electrons because I want 1 mole of zinc. So I'm going to take 2 times my number of Faradays. 1 Faraday is 96,485 coulombs. And my time is 10 minutes, so that's 60 seconds times 10 minutes. So when I do the math, I get 321.6 amps. Okay, it turns out that's not very realistic. The amount of current that most appliances draw is less than 10 amps. So we need about 30 times that. So what that tells me is that's too much current to be generating. What I have to do is use a more reasonable amount of current and figure out how long is it going to take. So 5 amps is a reasonable amount of current. Let's figure out, I want to do the same thing. I want to plate out 1 mole of zinc. How long will it take me? So my current is 5 amps. I still need the same amount of charge, so 2 times 96,485 coulombs. And now I'm looking for time. What I find time is going to be in seconds when I get the answer, so it's 38,594 seconds. Convert that, I get 643.3 minutes. It's about 10.7 hours. So electroplating takes a while. And remember, a mole of zinc is a lot of zinc. Formula mass of zinc is 65 grams. Most of the time when you're electroplating, you're doing tenths of grams, so it's not going to take nearly as long. So that gets us through the chapter on electrochemistry. What we're going to be doing for our lab is electroplating, and so you're going to need to use this information and figure out how to set up your lab and how to determine how much electroplating you're actually doing during the lab time available.